upcoming chemistry unit on periodic trends. Our focus standards will be Chem 1.2, 1.3, and Chem 1.5. We will start with atomic structures, go through periodic trends, and then end with chemical bonding. The purpose is to use formative assessments to monitor student progress and guide responsive instruction throughout the unit. This assessment plan is designed to provide ongoing feedback that informs both teaching and learning. By embedding formative checkpoints at each stage, educators can identify gaps in understanding early and adjust instruction accordingly to support all learners. The concepts we'll assess is the atomic structure, which are provided a explanation for. Students will identify the subatomic particles, interpret isotope notations, and analyze Bohr models to determine element identity. Periodic trends, students will compare elements and predict properties based on position. With chemical bonding, students will determine bond types using electronegativity differences and construct accurate Lewis structures for molecules. And then we're using a data-driven instruction, which analyzes item-level data from the formative assessment, and that helps identify common misconceptions and knowledge gaps. This analysis guides targeted reteaching and differentiated instruction. So, sample formative questions for the atomic structure. We're going to use a recall, a skill concept, and a strategic thinking question. We'll provide one question of each one on each level. For atomic structure, an example would be for recall, we use identify the number of protons, neutrons, and electrons in carbon-14. And so students demonstrating mastery of these questions would be allowed to proceed on to enrichment tasks that I have set aside, including predicting bond polarity, because they can understand all the questions that involve the atomic structure. Next is the periodic trends. Example of some of the questions that I have for those would include define the atomic radius and ionization energy. So, of course, the students would answer those questions. The way I'm going to gauge their progress is tracked by the communication. So through the learning management system, through the graded book updates, and then weekly check-ins with the students, and regular family communication on mastery, on the ones with the mastery level. Sample formative questions for bonding. One question would be to draw the Lewis structure for CO2, showing all bonds and ion pairs. With the communication, we're going to always make sure we're doing ethical grading practices. So we're going to report students' progress accurately and transparently. We're going to use a formative data to guide instruction, not punish learners for their gaps. And then we're going to communicate assessment purposes clearly to the student and their parent. So some anticipated misconceptions that we may run into with this unit is confusing atomic numbers with mass numbers. Of course, we know atomic numbers are protons only. Mass numbers are protons and neutrons. So we have to make sure that we control for this, because a lot of times this area is going to mess up the identifying of isotopes, and it's going to affect their calculating the subatomic particles. Thinking ionic bonds share electrons. That's a common error. They believe the ion bonds involve electron sharing like covalent bonds do. So we need to make sure we control for that. Misreading periodic trend directions. Students frequently confuse the direction of trends across periods versus diagram groups. Adding extra electrons to the Lewis structures. When drawing Lewis structures, students often add more electrons than available, or they violate the octet rule incorrectly. So formative assessments will help us identify and correct these errors through the responsive instruction in real time. And so some formative assessment strategies that we can use that will also help to build in comprehension and understanding is the digital exit tickets. which are quick targeted questions administered at the end of each lesson via Google Forms, and they respond in 2 to 3 minutes. And it provides an insight to us on understanding the concepts of atomic structure or bond types that they understand. Whiteboards show me checks, so students display answers on personal whiteboards for real-time assessment. It's ideal for checking understanding of periodic trends, electron configurations, and even the Lewis structure in instant visual feedbacks. The FET simulation checkpoints, interactive simulation activities with embedded checkpoints. So students explore their atomic models and bonding virtually, and then they answer guided questions that reveal where they are. And then peer feedback is a tag method. Students use the tell, ask, give to provide constructive feedback on each other's work. So this strategy promotes metacognition and allows immediate instructional adjustments based on the observed patterns. So the digital formative assessment, in the Google Forms assessment, the students answer a series of questions, which I went over those questions, aligned to CHEM 1.3. So the form provides immediate feedback. For example, if a student incorrectly identifies which element has a larger atomic radius, the form automatically displays a reteach graphic and a short explanation. So students can revise the answer before moving forward, which promotes mastery and it reduces their frustration that they got the answer incorrectly. So as you'll see here, it just breaks down Google Forms, what it offers, which we talked about, auto-graded items, immediate feedback, adaptive branching based on their responses, and embedded visuals. And then focus concepts, periodic trend was what we use. That assessment specifically targeted students' understanding of the periodic trends. So the platform, the reason I use Google Forms because this platform serves diverse learners. So for example, you have the text to speech compatibility, adjustable time limits, multiple response formats, visual supports for accessibility needs. So this demonstrates how the Google Forms digital assessment functions in practice, showcasing auto-graded items and immediate feedback features. Students receive the real-time guidance, as we discussed, on their understanding, allowing them to identify areas for improvement and track their progress towards mastering atomic structures, periodic trends, and chemical bonding concepts. Assessment data directly informs instructional decisions, enabling responsive teaching that addresses identified misconceptions. Ethical reporting practices ensure transparent communication with students and families about progress, maintaining integrity while supporting student growth. This formative approach strengthens both teaching effectiveness and learning outcomes. This scholarly source guided instructional and assessment decisions through the creation of this formative assessment. And thank you very